This is SpaceTime Series 28, Episode 128, for broadcast on the 31st of October 2025. Coming up on SpaceTime, are there microbes in the Martian ice? Discovery of a mysterious dark object in the distant universe, and NASA looking for new bids for its lunar missions. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that Martian ice might be the best place to look for evidence of biomolecules on the red planet. The findings, reported in the journal Astrobiology, are based on research showing that intact biomolecules from dormant microbes degrade far slower in pure water ice than in mixed soil samples. Scientists recreated Mars-like conditions in the lab and then suspended and sealed fragments of proteins of E. coli bacteria in test tubes containing either pure water ice or a mixture of water ice and ingredients found in Martian sediment, such as silicate-based rocks and clays. The samples were frozen and transferred to a gamma radiation chamber, which was cooled to minus 51 degrees Celsius, the temperature of icy regions on Mars. The samples were then blasted with radiation equivalent to 20 million years of cosmic ray exposure on the Martian surface. They then modelled an additional 30 million years of radiation to provide a total 50 million year time span. The authors found that in pure water ice, more than 10% of the amino acids, the molecular building blocks of proteins from the E. coli samples, survived the simulated 50 million year time span, while the samples containing Mars-like sedimentary material degraded 10 times faster and did not survive. 50 million years is far greater than the expected age for some current surface ice deposits on Mars, which are often less than 2 million years old, meaning any organic life present within the ice would be preserved. That means that if there were bacteria near the Martian surface, future missions should be able to find it. The study's lead author, Alexander Pavlov, from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says ancient microbes or their remains could be found in time in Martian ice deposits by future missions to the red planet. Pavlov says the results show that biomolecules, if present in the Martian permafrost and ice caps, could remain intact for over 50 million years, despite the harsh and continuous exposure to cosmic radiation. An earlier 2022 study, also by Pavlov and colleagues, found that amino acids preserved in a 10% water ice and 90% Martian soil mixture were destroyed more rapidly than samples containing only sediment. Now, based on those findings, the authors had speculated that organic material in ice or water alone would be destroyed even more rapidly than the 10% water mixture. But instead, they were surprised to find that the organic materials placed in water ice alone were destroyed at a much slower rate than the samples containing water and soil. That degradation could be due to a slippery film which forms in areas where ice touches minerals, allowing radiation to reach and destroy amino acids. On the other hand, in solid ice, harmful particles created by radiation get frozen in place and may simply not be able to reach organic compounds. Pavlov says future missions searching for life on Mars should therefore target locations with pure ice or ice-dominated permafrost for exploration, as opposed to studying rocks, clays or soils. Back in 2008, NASA's Mars Phoenix mission landed at the Martian equivalent of the Arctic Circle. There it undertook a shallow-depth excavation at the site, finding permafrost ice just below the surface. In addition to testing for conditions on Mars, the authors also tested organic materials in temperatures similar to those on the Jovian ice moon Europa and Saturn's frozen moon Enceladus. They found that these even colder temperatures further reduced the rate of deterioration. Pavlov says those results are encouraging for NASA's Europa Clipper mission that'll explore the icy crust and subsurface ocean of Europa, the fourth largest of Jupiter's 95 moons. Europa Clipper was launched in 2024 and is travelling almost 3 billion kilometres to reach Jupiter in 2030. It'll conduct 49 close flybys of Europa, assessing whether or not there are places below the surface that could support life. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, the discovery of a mysterious dark object in the distant universe, and NASA looking for new bids for its lunar missions. All that and more still to come on SpaceTime. Astronomers have detected the lowest mass dark object ever found in the universe. The discovery, reported in the journals Nature Astronomy and the monthly notices of the Royal Astronomical Society, has a mass about 1 million times that of our Sun. Its nature is unknown. It could be a clump of dark matter 100 times smaller than any previously detected. Or it might be a very compact, inactive dwarf galaxy. Finding more such mysterious objects and understanding their nature could rule out some theories about the nature of dark matter, that mystery substance which makes up almost 80% of the total mass of the universe. Scientists have no idea what dark matter is. They know it exists because they can see its impact on normal baryonic matter around it, keeping galaxies together as they rotate, and magnifying more distant background objects through gravitational lensing, the way gravity distorts light passing through or near it from a more distant background object. Now, because this mysterious object doesn't emit any light or other radiation, it too was detected through gravitational lensing. Based on the distortion, astronomers can infer the amount of matter in the unseen object. But this new object was so small, it was only detected by inducing a small pinch in the distorted image caused by the much larger object, sort of like a flaw in a funhouse mirror. One of the study's authors, Chris Fasnacht from the University of California, Davis, says it was an impressive achievement to detect such a low-mass object at such a large distance. Finding low-mass objects such as this one is crucial for learning about the nature of dark matter. Although imperceptible except for its gravitational effects, dark matter is thought to shape the distribution of galaxies, stars, and other visible bodies across the cosmos. A key question for astronomers is whether dark matter can exist in small clumps without any stars. This could confirm or refute some theories about the very nature of dark matter. To reach their findings, the authors used a network of radio telescopes in the United States, Europe, Asia, South Africa and Puerto Rico, using a technique called radio interferometry to create an Earth-sized super telescope by linking all these telescopes together and capturing the subtle signals of gravitational lensing by this mysterious dark object. Because it's by 100-fold the lowest mass object yet found by this technique, astronomers believe the method could also be used to find other similar objects. The study's lead author, Devon Powell from the Max Planck Institute in Germany, says that given the sensitivity of the data, this discovery is consistent with the so-called cold dark matter theory of cosmology on which much of science's understanding on how galaxies form is based. Having found one, the question now is whether they can find more, and whether the numbers will still agree with the models. This is SpaceTime. Still to come, NASA has called new bids for its Artemis moon program, and the giant spiral galaxy M31 Andromeda, the Crab Nebula M1, and 3 meteor showers are among the highlights of the November night skies on Skywatch. NASA has called for new bids for its Artemis moon program to compete against SpaceX. NASA Administrator Sean Duffy says he wants a space race in regard to American companies competing to see who can actually get the United States back to the moon first. Duffy expects to see companies like Blue Origin put in bids for the contract. He says that while he loves SpaceX and what they're doing, right now they're behind the projected timeline for the multi-billion-dollar Artemis program. Duffy says they've pushed their timelines out and America is in a race against China to get people to the lunar surface first. The upcoming Artemis 2 mission will send a 4-person crew around the moon aboard an Orion spacecraft in April next year, although that could be accelerated to as soon as February. And Artemis 3 is currently slated to land on the lunar surface South Pole in mid-2027. The problem is ongoing delays keeps pushing that date back. China is currently aiming to land its first taikonauts on the lunar surface in 2030 and then set up a joint lunar base with the Russians soon after that. US President Donald Trump, who announced the Artemis program during his first term in office, wants to see the US return to the moon as soon as possible, and he also wants to send the first humans to Mars. Duffy says both he and POTUS want to get to the moon during the president's current term in the White House, so he's going to open up the contract. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian and Etruscan mythical winged horse, who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. It's estimated to have about 185 times the Sun's radius and 12 times its mass. Epsilon Pegasi, together with the stars Markab, Al-Janib, Shahid and Alpha Andromedae, forms the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked-eye stars shaped like a square. One of the stars in this constellation is 51 Pegasi. 51 Pegasi is a Sun-like star located 51 light-years away. On October 6, 1995, astronomers announced the discovery of an exoplanet orbiting the star. It was the first ever confirmed detection of a planet orbiting another star. The planet has around half the mass of Jupiter and is thought to be a gas giant. But it wasn't what scientists were expecting. The planet orbits the star in just 4 Earth days. That's much closer than Mercury's 88-day orbit around the Sun. Because it orbits so close to the star, 51 Pegasi b as it's called, experiences temperatures estimated to be around 1200 degrees Celsius. Now, at the time of its discovery, this close distance was not compatible with theories of planetary formation, and it resulted in a lot of discussion among scientists about the idea of planetary migration. However, since its discovery, numerous other so-called hot Jupiters have been detected, pretty much confirming planetary migration to be real. By the way, a light year? Well, that's the distance a photon can travel in a year at the speed of light, which is some 300,000 kilometres per second in a vacuum, and the ultimate speed limit of the universe. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located around 33,600 light-years away. Globular clusters are tight balls containing thousands of stars, which are all originally formed at the same time out of the same molecular gas and dust cloud. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains around 100,000 stars, making it one of the most densely packed globular clusters in the entire Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars orbiting very rapidly around what appears to be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars including 1 double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're in or near the Northern Hemisphere and away from city lights, you'll notice a fuzzy patch of light right next to Pegasus. This is the giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in our local galactic group. Located some 2.5 million light-years away, Andromeda consists of more than 1 trillion stars, around twice the number found in the Milky Way. And it's huge, some 220,000 light-years across. Based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also has far less new star production going on than our galaxy. And the rate of supernovae in the Milky Way is also about double that in Andromeda. Andromeda is surrounded by a large, massive halo of hot gas and plasma, estimated to contain at least half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That's almost halfway towards the Milky Way. Using a good pair of binoculars or a backyard telescope, you'll see dark dust lanes in Andromeda's spiral arms, and you'll see its bright central galactic core. Now, over time, Andromeda will become a lot clearer. That's because it's getting closer. You see, the Milky Way and Andromeda are expected to collide in about 3.7 to 4.5 billion years from now, the two spirals eventually merging to form a new giant elliptical galaxy. What that means for the future of the Earth, the Sun and our solar system is a matter of great ongoing debate. The gravitational tidal perturbations from the encounter could rip our solar system apart, or even fling us out into intergalactic space. At this stage, only time will tell. Now, looking to the east and slightly south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. The brightest star in the constellation is Beta Ceti or Deneb Katos, an orange giant located 96 light-years away. The name Deneb Katos means the whale's tail. Another one of the stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 days, changing in diameter from around 400 to 500 times the diameter of our Sun. Also visible is Alpha Ceti, traditionally called Menkar the Nose. It's a red-hued giant star some 220 light-years away. It's actually a double star, with a secondary 93 Ceti being a blue-white star some 440 light-years away. Also in Cetus, located some 11.9 light-years away, is the yellow dwarf star Tau Ceti, the nearest sun-like star to the Earth other than the Sun. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and other characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. That's followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then comes spectral type G yellow stars. That's where our Sun fits in. Slightly cooler are spectral type K orange stars, and then the coolest and least massive stars known are spectral type M red stars. Each spectral classification can then further be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So, at the end of all that, our Sun is classified as a G2V, or if you prefer G25, yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but then became brown dwarfs after losing some of their mass. Brown dwarfs fit in a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. South of Cetus, you'll find the brilliant star Achernar, which means the river's end, and it marks the end of the river Eridanus. Achernar is a binary system, comprising Alpha Eridani, which is the brightest star of point of light in and lying at the southern tip of the constellation of Eridanus. The two components of Alpha Eridani are designated Alpha Eridani A and Alpha Eridani B, and they're located about 139 light-years away. Of the 10 apparent brightest stars in our night sky, Alpha Eridani is the hottest and bluest in colour. That's due to Achernar being a spectral type B main sequence star. Achernar also has an unusually rapid rotational velocity, causing it to be quite oblate in shape. The second star in the system is a smaller spectral type A white star and orbits the primary star at a distance of around 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which is roughly 150 million kilometres or just over 8.3 light minutes. Follow Eridanus towards the east and you'll see the magnificent constellation Orion the Hunter, a familiar signpost for southern summer skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova on July the 4th in the year 1054. They recorded the sudden appearance of a new star on their sky charts at the exact position of the Crab Nebula. The supernova appeared brighter than the planet Venus for weeks on end, before finally fading completely from view after almost 2 years. The Crab Nebula is located some 7,000 light-years away. It's expanding at a rate of over 5 million kilometres per hour. At the heart of the nebula is a rapidly spinning neutron star or pulsar, rotating some 30 times every second. It's emitting radiation in all wavelengths, from gamma rays and X-rays through ultraviolet, optical and infrared, and on into radio waves. Observations indicate the pulsar's spin rate is slowing down, and it will fall to just half its current rotational rate in the next 1,000 years. November's also a great time to check out the Pleiades or Seven Sisters, one of the nearest and most spectacular open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus. Now, depending on whose measurements you prefer, the Pleiades are located somewhere between 118 and 137 parsecs away, a parsec being 3.26 light years. The Pleiades are composed of mostly hot blue-white stars. Amazingly, different cultures in vastly different parts of the world all describe the Pleiades as seven sisters or seven women, possibly some sort of ancient throwback to very early human civilization. Just like October, November also sees three meteor showers. There's the November Orionids, as well as the Taurids and the Leonids. Although peaking in late October, the Orionids continue to sprinkle down during the start of November, and are usually at their best in the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter, hence their name. The Taurids are generated by the comet Encke, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Now, Encke and the Taurids are believed to be the remnants of a much larger comet which disintegrated sometime in the past 20,000 to 30,000 years, breaking into several pieces and releasing material by normal cometary activity and maybe occasionally through close encounters with the gravitational tidal force of the Earth and other planets. In fact, the cometary stream of material from the Taurids is the largest in the inner solar system, and being so spread out, the Earth takes several weeks to pass through it all. That means there's an extended period of meteor activity compared to the much smaller periods of activity for other meteor showers. Interactions with the giant gas planet Jupiter have also caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to around November the 25th, while the northern Taurids go from October the 12th to around December the 2nd. The Taurids are usually quite diffuse, only producing about 7 meteors per hour. However, they're composed of far more massive material. Think of pebbles instead of dust grains. And so they tend to produce a higher percentage of very bright meteors known as fireballs, produced by the larger meteoroids burning through the atmosphere. The southern Taurids should be putting on their best show just after midnight around now. The third meteor shower in November are the Leonids, which peak around November the 18th. They usually produce around 15 meteors an hour, but have been known to occasionally produce some spectacular meteor storms, with showers in 1999, 2001 and 2002 producing around 3,000 Leonid meteors per hour. But one of the best had to have been the Leonids meteor shower of 1966, which generated literally thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. Produced by debris from the comet Tempel-Tuttle, the Leonids radiate out from the constellation Leo the Lion. And they're a fast-moving stream, encountering the path of the Earth at 72 kilometers per second. Larger Leonids, which are about 10 millimeters across, can have a mass of half a gram and are known to generate really bright meteors. It's been calculated that the annual Leonids meteor shower can deposit 12 to 13 tons of particles across the planet. Jonathan Nally from Sky and Telescope magazine joins us now for the rest of our tour of the November night skies.
G'day, Stuart. Yes, it's definitely November, which means we're coming up to summer in the southern hemisphere here, winter, of course, in the northern hemisphere. Good observing weather for where I live, so it's a great time of year for stargazing. So let's start with what we can see in the early evening sky. When you go out after dark, the sun's gone down and the sky's sufficiently dark, you'll see the Milky Way, which is our galaxy seen from the inside, and it's sort of hugging the western horizon from north round to the south, sort of not far above the western horizon. And you'll be able to see the tail and the stinger of the constellation Scorpius, the scorpion, sticking sort of straight up from the western horizon. Scorpius is one of the few constellations that actually looks like the thing it's supposed to represent, a scorpion. It really does look like a scorpion. If you trace out the stars, you sort of do a join the dots thing. Right next door to Scorpius, we've got the constellation Sagittarius, which doesn't look like anything. Nestled in between Scorpius and Sagittarius, we've got another little constellation that most people have never heard of called Corona Australis, or the Southern Crown. It's a nice little sort of half circle of stars if you join the dots, and it is therefore another one of these accurate constellations. A crown is a sort of a round, sort of semicircle shape, and this constellation is a semicircle shape. There is actually also a corona borealis. There's a northern crown as well, in the northern part of the sky. Directly west and just above the horizon for an hour or so during November is a big, vast constellation called Ophiuchus. Most people haven't heard of this. Ophiuchus has the distinction actually of being the 13th sign of the so-called zodiac, which is defined as being all the constellations traversed by the sun's path across the sky. Now, astrologers have conveniently overlooked the fact that there's a 13th sign of the zodiac called Ophiuchus all this time because, of course, it just doesn't fit in with their sort of ridiculous superstitions. But then astrology and accuracy have never really gone together, have they? What a nonsense that is. Anyway, down in the south, we've got the Southern Cross, but it's hard to find at the moment. It's very low down on the horizon for most people, or even out of sight below the horizon for many others. The best time to see the Southern Cross, if you're really keen on seeing it, is from about March through to September, when it's up nice and high. In the southeast, down towards the horizon, we've got a very bright star called Canopus in the constellation Carina. Canopus is the second brightest star in the night sky. It's a little over 300 light years away, which is not too far in space terms, and it's a pretty amazing star. It's more than 70 times as big as our sun, and it's more than 10,000 times as luminous. Right? So imagine that, 10,000 times as bright as our sun, basically. So it's 300 light years away. Imagine if it was closer. I mean, if it was 30 light years away, we'd have a second moon in the sky. It'd be so bright. It'd just be amazingly bright. Now, higher up in the southeast, there's another bright star. It's called Achernar. Achernar, Achernar. It marks the far southern end of a constellation called Eridanus, which means the river, and Achernar is the ninth brightest star in the whole sky. It's about 140 light years away from Earth, so only about half the distance to Canopus. And unlike Canopus, which is a solar star, Achernar is a binary system, which is very common throughout the galaxy. The main star of this system, the second star is pretty small and insignificant, but the main star is about 6 times as big as the Sun and several thousand times as luminous. So it's not as big and not as bright as Canopus, but it's roughly half the distance away. You have to factor in these things. Even though a star might be intrinsically bright, how far away it is determines how bright it seems to us at this distance. Now, in the northern half of the sky at the moment, as seen from the southern hemisphere at least, it's pretty bare at this time of year, filled as it is with a bunch of big constellations that don't have very many bright stars. You've got Pegasus, the winged horse. You've got Pisces, the fish. There's one called Cetus, which is the whale. There's Aries, the ram, and there's that Eridanus river constellation I was talking about a moment ago. But over in the eastern sky, you've got the constellation Orion starting to poke its head above the horizon. This is the sign, stargazers, that summer is approaching in the southern hemisphere or winter in the northern half of the planet. Now, as the night goes on, as the Earth rotates, by the early morning hours, the sky will have changed quite a lot. So constellations will have dipped down below the horizon in the west, and other ones come up into view in the east. So Orion, by early morning hours, Orion is now high in the sky. You've got another constellation called Canis Major, with its bright star Sirius, which is the number one brightest star in the whole sky. That's really high overhead from where I live. And you've got Gemini and Leo and Cancer visible in the north. Fabulous constellations to explore with a telescope or even just a pair of binoculars. The end of the year is a really great time for stargazing, fantastic constellations and things up. For our friends in the northern hemisphere, of course, you've got the cold weather, so you have to rug up. But, as long as you've got some clear skies, it's very rewarding to see all these stars and constellations. For us in the south, we're lucky that it's summertime, the temperatures are nice and everything, although it does mean, of course, in summer, the hours of daylight are longer and the hours of nighttime are shorter. So we do actually have a shorter number of hours each night to go out and do some stargazing. Now, moving on to the planets, and there's only one of them visible in the evening hours this month, and that's Saturn. You'll find it about halfway up from the northeastern horizon. It's pretty easy to identify because there aren't any other bright stars around nearby to rival it, so it really stands out on its own. For the rest, you're going to have to be up at about 3 a.m. to spot the next two planets to become visible, which is Mars and Jupiter. They both rise above the eastern horizon at about the same time, about 3 a.m. Jupiter is quite big and bright. Mars is a bit dimmer and has a sort of a really orangey, reddy sort of colour, so that's fairly easy to identify. If you're up in the early hours of the 15th, or anywhere really from about the 13th through to the 17th, take a look at Mars and Jupiter because they come quite close together. They're only going to be about a degree apart or 2 moon widths apart on the 15th, in the morning hours of the 15th. So that should look pretty good as well. And finally, around 4:30 a.m., so you've got to be an early riser or a real night owl, we've got Venus coming up over the eastern horizon. Now, it's much bigger and brighter than Jupiter, so you really can't miss it. Venus is the third brightest thing in the sky after the sun and the moon. So we get a lot of people saying, "Oh, what's that really bright star out there in the morning?" I say, "Well, that's not a star; it's actually Venus." And sometimes Venus is visible in the morning sky, and sometimes it's visible in the evening sky, and it's what's become known as the evening star or the morning star, even though it's a planet. But it is normally really big and bright, and you can't mistake it for anything else. So if you go out and you see the brightest thing in the sky, if the moon's not up, then that's Venus. And that, Stuart, is the sky for November.
That's Jonathan Nally from Sky and Telescope magazine. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.